So we have a problem here that is going to deal with relative velocities. And it says that we are being chased by a bear in a forest where a marksman is waiting to shoot the bear with a tranquilizer dart. And it says that we have a velocity of 6 meters per second going 43 degrees northeast, and the bear has a velocity measured at 8 meters per second going 30 degrees northeast. And part A of this problem is asking, what are these two velocities in vector form? So as far as relative velocities go for part A, we have that our velocity relative to the marksman is equal to 6 meters per second going 43 degrees northeast. So this little y here is u, and the little m here is the marksman, representing u relative to the marksman. And then here, our this velocity is the velocity of the bear relative to the marksman, the little b relative to the little m, and that is 8 meters per second at 30 degrees northeast. And we actually have a little coordinate system up here, and it says that north is the positive y axis, and on the opposite is south being negative y. So we run northeast, east is the positive x direction, and west is the negative x direction. So running northeast gives us an all positive direction. So our velocity, the velocity of u relative to the marksman, would look something like this, going 43 degrees northeast. And then in a different color, the bear relative to the marksman, its vector would look something like this, going 30 degrees northeast. And what we want to do is we want to get these velocities in their vector form. So right now they are magnitudinal values, and what we want to do is get them into the form where we can see, because we're only dealing with x and y, we just want to get their x and y vector value. So the first thing we're going to do is we're going to take these two vectors and draw them separately from each other outside of this coordinate system. So we are going to be in blue at 6 meters per second, and then the bear is going to be in orange at 8 meters per second. And then we both have our respective angles up from the x-axis, being 43 degrees for us and 30 degrees for the bear. And so each of these two velocities must have some velocity going in the x direction. So both of these have an x component to their vector velocity, because you're running northeast, and if you just split it up, some part of you is running east. And then as well, there is a component of our vector velocity and the bear's vector velocity which is running north only, in the y direction. And that's just what we want. We want to split up our magnitudinal velocity and the bear's magnitudinal velocity into the separate x and y components that that makes up its vector form. And we already have the angles that we are measuring our velocity relative to the marksman from. So both of these triangles are just that. They're triangles that we can analyze using trigonometry to solve for their individual vector forms. So using the angles and the values that we know, we can just solve for the x and y components of each of these vectors on their own. So we can start with the velocity of u relative to the marksman first. So if we want to solve for the x component first, we can just say that we know that if we want the adjacent component and we have the hypotenuse, then we're looking at the cosine of our angle is equal to the adjacent, or we can just replace this with x over our hypotenuse. And then we just plug in the numbers that we know. So cosine of 43 degrees is equal to x over 6, and then we multiply by 6 on both sides. And then before we calculate this, let's just analyze the y component as well. So the y component will equal sine of theta, which is equal to y over the hypotenuse as well, because opposite over hypotenuse. And then this will be sine of 43 degrees is equal to y over hypotenuse, and then y over 6, and then we multiply by 6 on both sides. So then we can just take both of these values and write them as our x equals 6 times cosine of 43, and our y equals 6 times sine of 43 degrees. And this is just a matter of getting out your calculator and calculating these individually. So we can just do that real quick, and we get that the velocity of u relative to the marksman in vector form is 4.39 in the x direction and 4.09 in the y direction meters per second. And that's just the first vector, the vector velocity of u relative to the marksman. So essentially we just have to do the same thing for the velocity of the bear relative to the marksman, and we can just take a shortcut and go automatically to plugging in numbers in the same way that we did before, because our vector is in the same direction, the positive y and positive x direction. So basically what we just have to do is multiply our magnitude 8 times, and then the cosine in the x direction of its angle, 30 degrees for the x value, and then in the y value 8 times sine and then the 30 degrees. And then once again we can just calculate this out, and we get in the x direction that the bear's velocity is 6.93, and in the y direction exactly 4 meters per second. So we have both of these velocities, and they're both relative to the marksman. And with that, we can move on to part B.